Good morning students. Today we will study Helmholtz equation. Now this is also known as wave equation, and this is very important equation which we have to derive. Let us start with Maxwell equation. Del cross E is equal to minus del B by del T. This is Maxwell's second equation for time varying fields. Maxwell second equation for time varying fields. For static fields we have derived that this is equal to del cross E is equal to 0, but for time varying field del cross E is not equal to 0 but it is equal to minus del B by del T. Now here del by del T can be replaced as j omega, where W is the frequency, angular frequency. B can be replaced as mu h, where mu is permeability. H is what? H is magnetic flux density, magnetic field intensity, and B is magnetic flux density, okay, and the relation between magnetic flux density and magnetic field intensity is B is equal to mu h. So by replacing these two with this, what we will get? Del cross C is equal to j omega with a negative sign mu h. Okay, now taking curl on both sides, what will you get? Del cross E is equal to minus j omega mu del cross h. Okay, now we know del cross h is equal to jc plus jd. Again, this is third Maxwell equation for time varying fields, and jc is the conduction current density, and jd is the displacement current density. Okay, now again these are vectors, all these are vectors. Now we know that jc is equal to sigma E, where sigma is the conductivity and E is the electric field intensity, plus del jd is equal to del by del T of D, where D is electric flux density. So del cross H is equal to sigma E plus del by del T of D. Okay, so again del by del T can be replaced as sigma E plus j omega. D can be written as epsilon E. So this way, now E can be taken common. It will be sigma plus j omega epsilon. This is del cross E. Okay. Next what we will do, we will replace del cross E is equal to this thing on this equation. Let this equation be first. So put the value of del cross E in this equation. Okay, what we will get? We will get del cross E is equal to minus j omega mu E sigma plus j omega epsilon. Okay, now this thing del cross E, this is equal to del of del dot E minus del square E. Okay, so putting here, what we will get? We will get del of del dot E minus del square E is equal to minus j omega mu E sigma plus j omega epsilon. Okay. Now here del dot E, we know that del dot D is equal to rho V. This is our Maxwell first equation. For free space, there is no charge, so charge density rho V is equal to 0. Therefore, del dot D is equal to 0. Putting okay, now del dot D can be written as epsilon E is equal to 0. So this can be written as del dot E is equal to 0. Now del dot E is equal to 0. Putting this in this equation, what you will get? Minus del square E is equal to minus j omega mu E sigma plus j omega epsilon. This will give, we get minus minus cancels out. I can write del square E is equal to, whole this is taken as gamma square into E, which can be written as del square E minus gamma square E. This is known as the Helmholtz equation. Here gamma square is equal to j omega mu sigma plus j omega epsilon, and this is our propagation constant. Okay, so this is for Helmholtz equation for electric field. Similarly, for magnetic field, this would be del square H minus gamma square H is equal to 0. Thank you.